was
You were
scary.
so
All right.
I was.
Is my channel? It might take a couple seconds.
Refresh my page.
Hopefully the live stream starts up.
Not seeing it.
On mine, it now shows my live stream popping up. So let me know if you get that pretty soon. So,
To be on a different live stream.
anyways, okay. So we're finally up and running. Only about 15 minutes late. Let's jump into it right away. If there are any questions on anything, we can go over whatever you want. I'm here for this time, to answer whatever you need to go over. So, who's gonna start us off?
I will.
All right.
Okay, so for the homework problems you gave us, I don't understand. Let me just read it.
Sure.
Okay. It says, suppose you place a ball in the middle of a wagon, then accelerate the wagon forward. Describe the motion of the ball relative to the ground and to the wagon.
Sorry. Thank you.
No, that's okay. Is my stream showing up yet?
It's not.
What is it showing on my page?
We got live.
Can you go to?
I just want to
Yeah,
do a
check
whole packet
videos.
together. I think that's a really good place to start.
I think you should start at the beginning. I don't remember any of that.
And all the homework.
Did you have any discussion?
Well, gosh, that's not good. Well, then maybe what this is gonna mean is that we will have to.
Well, I'll tell Mr. Birdman what the work is like.
Oh my
Oh.
gosh, you just destroyed me. She got she got like starvation or something. No.
Oh, okay. So there's a little
Do we have to
bonus
be subscribed?
addition. This is such a pain in the butt. Okay, so let's talk about this problem up here. I'm updating the link on PowerSchool if you want to get to the stream. Otherwise, if you are not part of my classroom, this is the stream link. So, goo.gulf. QE4SZA. And I think those are the capitals there. And the capitals are important. Oh no, it's capital S, lowercase c. Okay. So those of you at home, that is the link. I hope you can see that. I'm going to get my face all up in there and make sure that they can. And I think it's going to be backwards. Oh no, they can't even see it. Am I in the way? I'm in the way. Yeah, you can't see it. That's great. Okay. goo.gl/Q capital E 4 capital S lowercase z capital A. All right. This problem out of the book. We have a ball in a wagon. We are going to push on the wagon, cause that wagon to accelerate. What is the ball inside going to do? What does the ball want to do?
Not move.
The ball wants to not move. What do we call that?
Wait, why doesn't it want to move?
Because what?
Newton's first.
Yeah! Newton's first law, the law of inertia. Right? An object in motion wants to stay in motion. An object in motion, an object at rest wants to stay at rest.
Unless actually.
So this thing's gonna want to not move. So the cart is gonna move. The wagon is gonna move. What is the ball gonna do?
Drop.
It's not gonna drop.
No, it's like drop on the ground, like if the wagon moves out.
Well, there's walls on the wagon.
It's
Oh.
going to move out of the wagon relative to the wagon.
Yeah. So this cart is gonna move. This ball is gonna look like it moves backwards.
Oh, but really, just like.
It's just like, have you ever been on a plane or a train or an automobile and you set something with wheels down next to you and then you get going?
Oh,
There was
like
one
the
time on a
ocean.
plane where I set my carry-on down before takeoff and it had wheels. And it
God.
slid all the way to the back of the plane once we started going off the runway. Nothing terrible like that has ever happened to you?
No.
It's the same thing that's going on here. We're accelerating in this direction, and this ball in the wagon doesn't want to move. So that's the ball's inertia wants to keep it where it is. So it's going to look like it rolls backwards.
Okay.
Where would we
then
find
what
your
would it
live
be?
video? Sorry.
No.
We're lost. We can't find
Did you go there?
it. Yeah. but it
That
says
should
you
be
have-
the link to my live video.
It says you have nothing. This is where it's at. Did you find it?
No, it still never came up for me.
My channel should be
Mike are probably
Are
watching.
you sure
Should be
it's
public.
live?
My shoulders are so
Yeah, my privacy is public.
This is nice. But he curved it so I got it. The phone, yeah. I don't know.
So apparently my stream is private.
Yeah.
Great.
This is fantastic.
Okay, now try.
I was pretty
What in the heck? Well, I guess because I was looking at it on my own account, it was fine.
Oh yeah.
Is it on there now? Great. Good stuff. So you'll be joining us late then if you're at home. But I'll upload this entire video to YouTube. So all of the screwing up, there will be 15 minutes of that at the start of the video. Well, it's like 10 seconds behind. That's as good as it's going to get. Okay, so we've gone through this. Do you understand this?
Yeah, but
Application of
then what would
Newton's
the
first?
relation to the ground be?
So relative to the ground, the ball is going to look like it's not moving,
Okay.
right? Because the ball wants to not move.
Yeah.
So you're going to move this, that ball is going to roll backwards, but it's going to seem like it's not moving relative to the ground.
Okay.
I can do a similar sort of demo. With a marker
Oh yeah.
in here. If I move this forward, right, the marker wants to move back because it wants to not move,
Okay.
right? If I move it to my right, it moves to the left, and then once it hits the side, it kind of bounces back. And that's inertia. That's because the marker wants to stay at rest.
Okay.
What else we got? We got a whole lot of content for the final exam, so we need to
I mean,
work.
I'll ask another one.
Oh yeah, that sounds good. What do we got?
Okay, can we just review like from the very first chapter,
The very first or like the first of?
like our first
The
unit,
way
Oh,
the waves.
like
the
the
waves.
waves and stuff. Can
Waves. What about
we
waves?
review the like is there gonna be stuff with the ripple tank on our final?
Very unlikely. It's much more important that you have the concepts of waves and the equations,
So,
So,
what are
like,
those?
like the vocabulary
Well,
and
we
the
have to, like,
equations.
Be able to draw like diagrams of them like bouncing off.
I don't think that that's super important.
Okay.
Wait,
Can you give us diagrams or
It's all
equations
multiple
and stuff?
Do what?
The vocab and equations that you said you're gonna need.
We can go over some. So let's look at our equation sheet to start with. Vibration, waves, and sound, this first chunk. We really only have 3 equations. We have F equals 1 over T. What is F?
Frequency.
Frequency. What's T? What time?
Like the time.
What do we call this? That's right, the period.
Oh my gosh, it's been
But so
so
period is
long.
capital T and then lower T is time.
Lowercase t is when we're just talking about some time interval. But this capital T is a very specific time interval. Time for one period. So we have F equals 1 over T. V equals F lambda. What's V?
Velocity.
F we've already said is frequency. And what's our upside down Y, our lambda? Wavelength, yes. What is our units on velocity?
Meters per second?
Yep.
Okay, yeah.
Frequency? Don't all talk at once.
Hertz.
Yeah, hertz. And wavelength. Wavelength is in meters. Remember, hertz is also 1 over seconds. So if we have meters times 1 over seconds, we're going to get meters over seconds, which is what velocity is. I want you to be careful with that because at least in my class, students loved to screw up our units here. Give me some real funky stuff. Wavelength in meters squared over seconds squared and all sorts of fun things. So make sure your units make sense. I take off points for having your units wrong. I hope the other teachers do that because that's important. Then we only have one other equation, really minor. F sub b equals F1 minus F2, absolute value. This is just saying that your beat frequency is the difference between your two frequencies. I mean, this is the sort of thing we only took about 2 minutes in class to talk about, but this is technically an equation from this unit. On your equation sheet, it doesn't really show up. Oh, no, it does. You got F sub beat, it's just in really, really small letters.
Oh, so we get this on the final, right?
You bet your bottom dollar you do.
And then we do, so we don't get a note sheet?
No.
Or is it- okay, no.
No. You
And
don't
then
get a note card or
no
anything,
card?
but you do get the whole equation sheet.
Can we use our own
the-
equation sheet?
No.
Okay.
You'll use one of my class copies.
I don't like that because it gives us a bunch of
Yeah, like,
things that are
can we-
totally irrelevant to what we're doing.
Yeah, I hate that.
That's
Well,
what,
and
that's,
you have to
that's what I don't
remember to
like.
write
Well, then-
it stresses me out.
The idea is that you should be familiar enough with them, like you don't need to memorize everything, but you should be familiar enough with them to say, okay, I know I need that wavelength equation. Okay, yeah, I'm going to use this one.
But for the two, like, that are in the linear motion section, they don't have the squares, like, you can't see them.
Yep.
So,
You just come home.
What I'll do before the final is I'll say,
can we write it on
write this down if it's not on there. Most of my class copies have gotten that written down now. Maybe some are missing, so I will be very explicit
Okay.
about that. You should know that by now, though.
Well, yeah, you never know.
Okay, what else? Oh wait, you wanted
The
some more vocab.
would be-
Okay, so we've already got some vocab words here. We've got beat frequency. We've got regular frequency. We've got period, velocity, wavelength. Are there any there that you want me to be very specific about what the definition is? I think seems like we all sort of understand these, but
Wait, what is it called when two waves are on top of each other and then it gets, like, bigger?
constructive interference. What's the other type of interference?
Destructive.
Destructive. Yep, if they add up, if they're on the same side of our medium, it's going to be constructive interference. If they're on opposite sides, they're going to be destructive.
Okay.
Some more vocab. What is resonance?
Oh, that's
The
what-
natural frequency of an object.
Well, that's
That's when it
different.
vibrates, kinda,
Resonance
right?
is when it vibrates at the natural frequency. And so what's the natural frequency?
Hertz.
It's more for, like, isn't steel have, like, a high frequency or something?
Well, just tell me what,
Oh.
just conceptually, what is the natural what does natural
Oh.
frequency mean?
What an object vibrates at without an
like naturally.
Yeah, well, no, that's pretty much right. It's the frequency an object wants to naturally vibrate at, right? Like if I hit my chair, right, you can hear that a little bit. It has a natural frequency. Now, when I hit it, I'm not making it vibrate at that natural frequency. I'm making it vibrate at a bunch of frequencies. But what's going to happen is the other ones die out. The only one that's left is its natural frequency. That's the same reason that when I took the metal pole and bonk it against the ground, you know, you get that really piercing, shrill noise. That's because all those other frequencies die out very, very quickly, and all you're left with is that really high-pitched, annoying whine.
That's like why the glass breaks, right? When it's like that high.
Tell me why the glass breaks.
Oh no, I don't know.
Because the pitch is like higher than
The pitch,
It's a perfect frequency. Like it's an exact.
the pitch,
It's a clear
and the natural
pitch.
frequency combine to form constructive interference, making it vibrate at a higher amount and causing it to shatter.
Causing
The
what
glass.
about it? What about its wave pattern is increasing?
The crest, like the
Yeah, the amplitude.
That one.
Yeah, yeah. So what we want to do, right? What they did in that video is they determined the object's natural frequency. Then they mimicked that same frequency with an oscilloscope and just cranked up the amplitude. And that is going to cause the glass to vibrate. And as you increase that amplitude, that's going to increase the actual size of the vibrations. And eventually it just shatters. Yeah, that's how that works. So that gives me another one. We just did amplitude. What is the difference between period and wavelength?
Period is the amount of time, or wavelength is the amount of, just like the distance between
From where to where?
crest to crest or trough to
The
trough.
same spot.
So if I have a wave like this, from here to here, distance-wise would be the wavelength. But if I knew the time it took from here to here, then that would be the period. Be careful there. This was something that some of my students got tripped up with on one of our quizzes.
Oh my gosh, everything just like comes together.
It's great, isn't it?
Yeah.
Yeah. Because we had like some harmonic questions too. It's like, whoa, it's all coming together.
It's crazy. Physics, man. Some other good vocab. What is a harmonic? What's a harmonic?
Oh, that's
Doesn't
like
like the waves like go back and forth.
like there's like a first
Right.
harmonic and like second. Right?
There is like a first harmonic and a second harmonic. What are they?
Just
The
like these
bottom
like,
Then there's more waves, right?
Well, just tell me what a harmonic is.
I don't know what
Isn't it when the amplitude is like
A node?
Yeah, and then like
Oh wait,
it
never
just
mind, the
goes
node
back
is
and
in
forth.
the
Oh,
middle.
I forgot.
The node would be, so if this is my standing wave pattern, these are going to be my nodes.
Oh, that's what I was talking about. but
Yep, the
that's
points that look like they're not moving. The antinodes are going to be the points that look like they're moving the most. So what harmonic would this be?
That's the
Yeah, it's the third harmonic. We have 3 antinodes.
Oh.
I'm really this confused me.
If this is my string, and I have it just moving up and down like this is going to be my first harmonic.
Because it's just like
It's
one.
one vibration. So like
Well, there's another name for first harmonic. Could you maybe guess what that is? That's right. The object's natural frequency. Our first harmonic is our object's natural frequency. Our second harmonic, then, is going to be what multiplier of our natural frequency? 2 times our natural frequency. Our second harmonic would look like this. Yeah. where we now have two antinodes. Our third harmonic would look like this, and so on and so forth. Other good vocabs.
Wait, can you go over beat frequency again?
Beat frequency, I mean, just real quick and dirty explanation. If you have two frequencies that are really close to each other, when you hit those two tuning forks, you're going to hear that sort of pulsing. Or if you're tuning a guitar, that's, I think, the one that most people understand a little bit better. When you're tuning a guitar and you get close to the note that you're trying to tune to, you're going to start hearing this wow, 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 wow. And as you get closer, that's going to speed up. It's going to be wow, 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 wow. And then eventually it's going to go away.
Okay.
And then you're just perfect. And then that means you're right on the same frequency.
So like, what would a drawing of that look like then? Like,
you would never do a drawing of it.
Oh.
If you did have to do a drawing of it, and I can promise you won't, remember when we did our tuning fork lab, our beat frequency thing wound up looking like this.
Oh, yeah.
So you had like a wave that would get bigger and smaller, and the frequency of this large wave was your beat frequency. Yeah.
How do you find the frequency when you have like the two pitches again? Like, isn't it like subtracting them or?
Yeah. All it is you subtract your two frequencies, and then it's your absolute value.
Oh.
So your beat frequency is always positive.
Oh.
That's all it is.
Can you go over shock waves?
Yeah, that's a good one. So let's look at some shock waves.
Yeah.
I don't remember shockwaves.
Shock waves. So I've got my supersonic plane.
Oh yeah.
I will attempt to draw a plane.
Shockwaves.
That's pretty good for me. So what we're going to have is we're going to have something like, let's say like this. And usually what we're going to be given is we're also going to be given the speed of sound. So the speed of sound might be, oh no, it wouldn't be like that. We want the speed of sound to be reasonable here. So what would we want to do? We're going to say that, I think the way it was worded out of one of the packets was you do this line segment, the total distance it travels over the line segment of the sound. So we would say like, maybe we'll just do it this way.
So like the radius of the circle is how much farther it's traveled?
Yeah, so let's just imagine that, so this is going to be the speed of sound. What's the speed of sound in air? 340 meters per second.
Oh, 9.8, that's gravity.
That's gravity, and that's acceleration, so that's meters per second squared.
Are we going to have to, like, know that off the top of our head?
I don't think so.
Okay.
Well, you should. But I don't think so. So this is some distance, right? It doesn't really matter, but we know that this is the speed of sound. So sound travels this distance, and that's sound's speed. Then let's say from here, we have, these two chunks, and each of these chunks is the same distance. So then what is the speed that the airplane's traveling at? We would do this total distance over this distance, right? So we would just say it's 3 over 1. That means our plane is going to be traveling at Mach 3.
What's a Mach?
A multiple of the speed of sound.
Oh. Are we going to need to know that?
Yes. Which means I'm traveling at 3 times 340 meters per second. or 1,020 meters per second.
You said a Mach is a multiple something.
Yeah, like Mach 1 is the speed of sound. 1 times 340. Mach 2 is twice the speed of sound. 2 times 340. Mach 8 is 8 times the speed of sound. 8 times 340.
So no matter what, that circle is like the speed of sound.
Yes,
In
the
that
circle is
diagram.
always going to represent your speed of sound, whereas the cone is going to represent the speed of your plane.
Oh.
Yeah, here I have my notes back.
Yeah, good.
I don't think we ever learned
I
that.
don't know, but
I mean, it's not super important, but I'm going to say you should try to
so,
know
like,
Mach.
you could just say the speed is 3 times the sound, or
Sure.
if
That's what we
Like,
do.
it's the
Just
same
say that.
Mach is shorter and it makes you sound like a scientist.
can.
Yeah.
I don't know.
What else we got?
It's gonna be a Scantron, right?
You
Oh,
bet.
Thank God.
100 questions.
Oh, that's not
What?
that bad.
So it's just a
100?
Scantron in the lab practical?
That's not
Yeah,
that bad.
so the full final exam is
Could be
the
worse.
lab practical portion plus the written Scantron portion.
I always like
And the
100.
lab practical is 1/3 of your overall final grade.
And then
Okay.
the
And the Scantron is then 2/3 of your overall final grade.
So
And
we're just
how much
by
of our grade?
ourselves and we just go in the back.
You're by yourself. Yep. Well, I'm gonna have stuff set up all over the room because I have to have 30-some stations ready to go.
Oh, so it's just like whatever stations we get to.
Yeah. Well, what you'll do is there'll be 5 people starting at station 1, 5 people starting at station 2, 5 that kind of thing.
Oh.
And then after 8 minutes, we'll just rotate. So.
Oh, so we're not gonna be like just alone all the way back.
Well, I mean, you're working by yourself.
Yeah. It's not like
It's not going to be like everyone staring at you while you do your lab practical. No.
is that so we have the time to do the Scantron and that?
The lab practical is next week, Friday.
Oh.
So we'll do it during class, and then the final exam period, you'll have the whole 90 minutes to do the Scantron.
And are those like the Scantron and the lab practical? Are those like put together in one big like?
Yes.
How
So
many-
those combined are that 10% of your final overall grade.
Are they each like 5% or does it not?
No.
Like,
Well, because the lab practical is 1/3, so you can think of it as that
Oh.
being 1/3 of the 10%, 3 1/3%
okay.
of that 10%. So I mean, if you really punt the lab practical, then that means you're losing 3% in your total overall grade.
How much can that bring your grade up, letter-wise?
If you do well, I mean, if you're at
If you get a C, like your grade stays the same. If you
Like on the overall final.
generally, yes,
Yeah.
that will be the case.
So on the overall final, it like can't bring you more than the letter grade.
I think you'll be okay. I really do not want you to stress about the physics final.
That's the only one I'm stressed about.
Yeah, that's
No, I'm stressed about Spanish.
Everyone's your grade by like
It is really hard.
okay.
It's really hard.
Thanks.
What?
Thank
That's
you. Yeah.
helpful.
No, I'm stressing about you.
No, don't stress out about it. So
I'm a,
Because if I do bad on this,
I'll tell you this.
I will
It
not-
is curved.
Curriculum will be easy.
It will
Oh.
be curved.
Oh, that's
I
nice.
did that.
You did
Okay.
it front and back.
So then you're
I
fine.
guess.
And it's
Yeah.
exactly
Trust
the
me,
same.
it's really hard, but since it's curved,
Pretty much.
the idea is that
True.
we wanted it to be really hard so that the students that already, would get like an 80 on it, get either a perfect score or even get above 100, because I think that students that work that hard deserve that little bit extra bonus. And it also means that the students that struggle on it a little bit more still aren't ridiculously punished. So the idea is we wanted it to be really challenging even to the top level of students so that that curve winds up basically helping everyone. If we had the test be relatively
Oh, I
easy,
see what you mean.
then if there were students that really just were missing one huge concept, then there wouldn't be as much of a curve because most students found the test to be a little bit easier.
I want 100.
You want
You're gonna have to know
100
this stuff.
Theoretically.
Wave interference?
Well, what's your current grade?
Like,
Um,
is
92. 'Cause I think
Pretty
I'm
basically.
don't know what type
I
of
mean,
A.
And you want
If I have,
100.
Just wait, you want 100 for this class?
Okay, just put like 98. 98. Because that's not.
You're gonna have to get like
100.
300%.
152%.
exactly how you like. I
Are
know.
you guys like gaming your grades here?
Yeah, she's
Yeah.
got a website. You can go on. Yeah, you
So-
got 152%.
If these, both have an amplitude of 4 and they overlap, what is my resultant wave going to look like?
0.
That's going to look like nothing. I'm going to have a flat rope. What is it going to look like after they interfere?
They're gonna look the same on opposite sides.
Yeah, the same but opposite.
Oh,
This
wait,
4
wait.
is going to just keep moving that way, and this 4 is going to just keep moving that way. So we're going to have this over here, and this over here.
Oh, wait, when is it the circle then? When they meet up?
Well, it's 0 when they meet.
What is
Because
it to get an
when-
A and
when
not
do
an
you
A minus?
92.
Oh no, they would cancel each other out, not meet
Yeah.
together.
Yeah, so they would add if they were both on the same side. So what if we had 4 and 4? We're going to have 8 in the middle.
That's what I was thinking. I'm more like,
But this does math.
That's true.
Just understanding this concept is going to be all you need to do. It'd be really hard to have that as
So-
Scantron.
So for this, like, we're not gonna. I kind of forgot when you have like the two coming at each other, and then you change like the. I don't know how to describe it, but when you take the 2 points, and then you like draw a line.
Yeah.
Are we gonna have to know that? I don't know what that's called.
Well, so the reason it works that way on there is because you have the grid. Again,
Oh.
that's way more
That's the only thing.
putsy than we want on a final
Okay.
exam.
So as long as we know that, we should. be
You
fine.
need to understand the concepts. We're really
Okay.
testing your concepts. I think that's a little
Okay.
nitpicky. Other questions? I'm here for another hour and 45 minutes. Tops.
Can you do like a velocity time graph and like the accelerate?
You betcha.
Oh, yeah. Oh, sorry. I totally was not thinking.
okay.
Velocity versus time graph and what's scenario.
I got a balloon for my birthday.
Okay.
Because I really did. Look in my office.
It's
Still
still
there.
floating?
Yeah.
Just blow it up.
Wasn't your birthday like before break?
Yep. End of November.
Oh, it's a big balloon.
Oh my gosh, who got you that?
The science department. It's very nice of them.
That's the balloon in the pool deck.
So I got a balloon for my birthday, but I am a careless man, and I'm bringing it out to my car, and I let it go.
Aw.
What's gonna happen to the balloon?
Float up.
Oh,
It's gonna float up, and I'll tell you something. It's gonna accelerate up. So I am some sort of physics guru, and I recognize that my velocity time graph is going to have a particular shape, and I even know its velocity at some particular times. So what we are going to have is we're going to have something like this, let's say, and then this. Let's do... Let's make these numbers real easy. Draw my acceleration time graph.
acceleration. Isn't this velocity versus time?
Yeah,
Yeah.
this is velocity time. Draw my acceleration time graph.
Oh, okay.
You can do it.
No idea.
It's just constant.
Well, not the end.
What's your keyword?
Constant.
Well, what's your keyword for going from velocity to acceleration?
Mo-
Slope!
Oh,
There's your hint. Draw your acceleration time graph. While you're doing it, I'll do it.
Also for the wavelength one or whatever, is the T equal 0.40403?
Yep.
A big one.
You'll need to know it.
I already have
What is that the equation for? For what? No. What is our T equals 0.0403?
Pendulum.
sound wavelength.
What?
Wait, it's
I don't
not
know.
a
It's
sheet.
It's the pendulum.
T equals 0.0403 seconds squared over centimeters times L. What is that our equation for?
Oh.
Pendulum.
Period of a pendulum.
Oh, are we gonna have
That's so
pendulum
long
stuff in the
ago.
final?
What?
Are we having pendulum stuff?
You betcha.
Can you go over that? I sucked it. I don't even remember
yeah.
that.
Can we
I
finish this
remember
problem
all
and
my
then
data was
go
really
on?
far off in that lab.
Yeah, let's wrap this up real quick. So the only thing that I wanted you to do here, so we've got our velocity time graph. The slope of my velocity time graph is my acceleration. I'm recognizing here that from 10, 20, 30 seconds, I'm going to have the same slope, right? My rise over run is 15 over 10, 15 over 10, 15 over 10. Therefore, my slope there is 1.5 for those first 45 seconds. Then after 45 seconds, my slope is 0. I'm not increasing anymore. My acceleration drops to 0. So then we want to look at period of a pendulum.
I don't know. My phone's right here for once.
So our equation for period of a pendulum is, I think it's t squared equals 0.0403 seconds squared over centimeters times L. And L needs to be in centimeters. So the only thing is, for a period of a pendulum, you either have to know period or you have to know length. What if I said I have a 5 meter long pendulum? Find its period. Well, all you do is you take this, 0.0403, multiply it by 500, right? 5 meters is 500 centimeters. And then you're going to take the square root of that.
Oh, then that's not too bad.
Yeah, it's not too bad. It's just remembering what this is used for. This is just going to be for period of a pendulum. You have to be given the period or the length of the pendulum.
What unit is your answer?
Period is going to be in seconds. And really, this is just how we started the year off, so we could do that little lab investigation. This is really the only result we got from that. So pretty much all you need for pendulums is this equation. So if you see anything about pendulums, that should be the only thing you gravitate towards. What else we got?
My haiku, it says scientific thinking. What does that mean exactly?
That was our first unit, and really that's something that we've been doing kind of as we go along. Things like, how do you know that you're collecting good data? I put that on there because I think that recognizing those things are going to be really important for the lab practical, because you're going to be looking at data, analyzing data, collecting data, using some equations, using the data you get. So it's going to be like if you recognize, okay, if I need to calculate the acceleration due to gravity and I only have 8 minutes to do it, but I still want to get a good value, what am I going to do? Am I going to just drop something from 4 centimeters and time it? Am I going to try to drop something from as high as I can and do it 5 times and take my average? Am I going to use I guess most of the time the equipment we're going to be using is just stopwatches, but like what kind of equipment would you want to use if you had the option? Just some of those habits of mind that we've been trying to cultivate over the semester. We didn't really have a unit specifically on scientific thinking.
Okay.
Yep.
If we don't use gas, are we going to get downgraded?
On the Scantron, no. The Scantron, it's getting graded just by putting it through the Scantron grader.
Okay.
So, front and back of that Scantron is all that we're caring about. I think that's mostly because Mr. Bergman has been grading tests for 20 years, and it's got to be a lot. I was actually pretty relieved when I found out that the final was administered via Scantron, because normally tests take me a long time to grade.
Was it not in the past?
I think it was for quite a while, but in my experience, I've never done a Scantron test. Granted, I only have 9 months of experience, so.
Are we gonna need to know how to calculate the sources of error calculation?
Oh yeah.
Like when we do that.
Percent
for our
error?
lab?
Yeah, percent error.
I can give you that.
Like is that because that's not on our equation sheet, is it?
No. Percent error is going to be experimental minus accepted divided by accepted, whole thing, absolute value, times 100%. So this is going to get you your percent error of an experimental value if you know that there is an accepted value.
So if you don't know the accepted value, you can't do that?
Generally, yes. With the car lab, I kind of faked one out. I basically said you need to be assuming that your accepted value is your y-intercept, or your accepted value is, what your data told you, and then you need to calculate your experimental value. But if this sort of thing shows up on, the lab practical, it would very likely be, it would be something like do a little 8-minute lab to find the acceleration due to gravity, and then compare that to the accepted value for the acceleration due to gravity. So what would you use for your accepted value? 9.8. And then whatever you got would be your experimental value.
Okay. And then, can you go over a free fall problem?
What about it?
So does it always increase by the same number?
Mm-hmm. If I'm accelerating at a constant rate, that means my speed is increasing at a constant rate. So acceleration due to gravity doesn't change. That acceleration of 9.8 meters per second squared means that each second my velocity increases by 9.8 meters per second.
Okay.
So after 1 second, let's round it to 10. After 1 second, I'm traveling at 10 meters per second. After 2 seconds, I'm traveling at 20 meters per second. 3 seconds, I'm traveling at 30 meters per second. But then we're going to have this relationship d equals 1/2 at squared. That's going to give us the distance we travel. So our distance is going to increase exponentially.
Thank you.
See ya!
Wait, what is that the equation for? Just distance?
D equals 1/2 at squared. This is the distance an object travels under constant acceleration.
Okay.
Constant non-zero acceleration. I think that's all we want you to do here. Let's see if anyone's wrote in. Oh, we have a write-in. Okay. Maybe he was answering, because I see here a multiple of a frequency. So I wonder if he was answering when I asked what a harmonic was.
Oh.
Thanks.
But who
I
was
needed
it?
that anyways.
Doesn't matter who it was.
Oh,
Don?
You want to give him a shout out?
yeah.
Thank you.
There's four people watching now.
Oh, wow.
I'm popular. I should monetize my stream. Any other questions?
For the lab practical, are we gonna have to actually collect data?
You bet.
No.
Do we
I mean,
have
of
to,
course, it's going to have to be something that you can do in 8 minutes.
Yes,
Okay.
it's pretty short.
So would it just a stopwatch type?
It
of
would
thing?
probably
it wouldn't
be,
hooking
fair-
up to the computer.
No, it would probably not be anything where, it would not be
where
like...
we walk towards it. It wouldn't be anything like that.
Maybe it would be something like walking towards a motion detector.
But will the detector already be set up?
Yeah. Anything that you need for the lab practical will be set up and ready for you to go.
Okay, so we'll just have to click start.
Yeah, basically.
Perfect.
I want it to be as painless as possible.
Is like the lab practical graded like how you had it last time, where you had to like do a certain amount of things for an A and
Nope.
like?
This one is just graded normally. Each section is going to be worth, let's say, 10 points.
What does like a section consist of? Is that like introduction, or is that like, what does that mean?
So there's going to be 5 different lab practical stations, and each one will have a number of questions that you need to answer.
Oh, okay.
So it's not like, I don't think there's any of them that's just one thing. It will be, you need to get something, and then you need to maybe use that to evaluate something else, that sort of thing.
Okay.
But they're all relatively short, and I looked over it, and I really think that, if you look over your labs, you're going to be in good shape.
Okay.
Graphing by hand.
Can we like use our?
I think you will have access to computers if you need to do any graphing. I don't even like having people graph by hand. I don't like that.
So will it all be Logger Pro though? No graph analysis.
Is it it's the MacBook or our Chromebooks?
Well, for my class, it'll be on these. So I think if you're in 140, you'll use the computers in the back too. So you'll be using, you'll be using Logger Pro.
And then for these that we did today, when we like have our answer, do you want us to keep it as like square root of something, or do you want us to put it as a decimal?
I like decimals. I mean, I guess I don't really care, but I think like the square root of 98, that's pretty dang close to the square root of 100. You can approximate it as 10. We do that with gravity.
Yeah.
Okay.
We did it as 10.
Okay.
Because I think you get something like 9.9.
Yeah.
Yeah, we put ours as 10.
Round that off to 10.
Can you go over the difference of the 2 types of waves, like the transverse and the?
Sure. Transverse and longitudinal. So what's a transverse wave?
So
Transverse.
I think it's like.
That's the like up and
Coming
down.
up and down.
Yeah.
Yup. Transverse waves, the medium is going to oscillate up and down. Longitudinal, you're going to have your medium compress and expand, or you're going to have what we call compressions and rarefactions.
That's like, wasn't there an example of something with a window for that one? Or is that something else? Like when you close a door and there's an open window with like curtains.
Wait.
There was something like that in the book, I thought.
I remember what you're talking about.
Sure.
It's like when the windows
When you close a door,
So when the curtain
you're
will come in.
compressing that air from the door, and that compressed air is going to move across
and, like,
the
if
room.
you open the door.
And if you
it's
open the
probably a
door, that's going to
rarefaction.
suck air from the curtain
Okay.
and move it out.
What were the different parts of the longitudinal wave called?
So this is a compression,
Okay.
and this is a rarefaction.
What? I'm just looking on IQ.
I'm looking at Haiku too.
Can you explain what we did in class today when we did the friction was equal to the force that was pulling it?
Mhm.
Yeah.
So friction is weird. Friction is very weird because it is like a smart force. I mean, friction is just the interaction between two surfaces, but it knows when to increase and it knows when to decrease. And there are 2 types of friction. It's very weird. What we're talking about today has to do with that oddity of friction. So friction, I guess the way that I'll want you to know it, basically, friction has like a maximum value. And once you go above that maximum value for friction, then that object's going to start moving.
Oh, okay.
So, if I have something that, if I have a surface that is going to be able to withstand, let's say, 50 newtons of friction, once I pull with greater than 50 newtons, or even 50 newtons, then that means that my object is going to start to move. And if I exceed 50 newtons, then it's going to start to accelerate.
So on here, we had like, so the crate was like starting to move a little bit with constant velocity, so the friction was equal to it.
Yup. Constant velocity means no acceleration, means no net force.
So even though it's moving.
Even though it's moving. Remember, you can be moving with a constant velocity and not be experiencing any force. I mean, when I throw this across the room, there's no force on it except for gravity down, but it still moves that way at a constant velocity.
Okay.
Can you explain like what a net force is or how to find that exactly?
So net force is just like what we were doing today. And really the reason we want net forces is because in this F equals ma, this marker's starting to go. In F equals ma, what we really care about for F is we really care about F net. Because if I have an object with a normal force and a force gravity, well, this force gravity is not equal to ma. This normal force is not equal to ma. I need to determine the net force on this block, which if it's just chilling out there, my normal and my force of gravity are going to be equal and opposite. So Fn net here is 0. So if 0 equals ma, well, that means A has to be 0. So the way we're going to calculate net forces, this is just vector addition like we did today. If I have an object with a tension, let's say 7 newtons, force of gravity of 5 newtons, and
Wait, we didn't go over how to do it when it's at an angle like that yet.
no, you're fine. Yeah, we did.
No, we only did it when it was either straight up and down or straight to the side. You said we would do the bottom two tomorrow.
Oh, we did. We did the bottom 2 in all my other classes.
Oh.
We just didn't have time in your class.
Oh.
Is this gonna be on the final, like vector addition and stuff?
Oh, yeah. And it's much more important on the actual forces test next week. The final, it would be kind of silly to have the forces test and then still have a ton of stuff on the final about forces, especially because they're 2 days, well, I guess a week apart. So the forces final is going to have a lot more. Let's do it this way then. Yeah, we probably don't want to do those sorts of angles because I don't want you to have to do trig. We'll just do it this way then. I've got what is with these markers? So we've got a force tension of 5 newtons, a force tension of 3 newtons. And then we would have maybe, no, this is what we got. So something is suspended by 2 strings, and we want to know.
Go home.
That scared me.
We're reviewing for the final.
Wow, you guys are early.
Yeah, we got one every day,
Wow.
But there's one
Every
every
teacher's
day.
taking a different one?
except for weekends and next Wednesday. Yeah, we're split, dividing and conquering.
That's nice.
Yeah.
Excellent.
So if I want to find the net force here, yeah, I think we'll be going home as soon as we can. If I want to find my net force, I'm going to do my vector addition. I'm going to go tip to tail. I've got 5 newtons up, I've got 5 newtons down. 5 up, 5 down. What's my net there?
0.
0. Then I've got 3 to the left. So I have 0 and 3 to the left. What's my net force? 3. What direction?
To the left.
To the left.
Do you have to write that like to the left?
You bet.
Right, west or like just left?
3 newtons
Okay.
to the left. 3 newtons left. 3 newtons westerly. I don't care, but When you give me a vector, you better give me magnitude and direction. Right?
Okay.
That's the whole point of a vector. So here we have a net force of 3 newtons to the left. Let's just for fun, let's say this is a 6 kilogram block. Let's use F equals ma. Let's find the acceleration of this. My net force, we've already said, is 3 newtons. My mass is 6 kilograms. All I got to do here is divide by 6. I'm going to have an acceleration of 1/2. 1/2 what?
Meters per second.
Meters per second squared. That's why we want our net force. Because we cannot use Newton's second law, we don't have our net force.
Okay.
And most of these are going to, if you need to do this, they will be relatively straightforward. I won't make you do anything at crazy angles. I'll try to stay away from having you do trig.
Okay.
Thank you.
Clearing out? We're dropping like flies.
I'm gonna go home.
You're welcome to. I mean, when you guys leave,
I have to wait for my parents to come.
I am achy.
I have to walk home,
I have to do
but I
it
live like really close, so I should know.
Don't worry, guys. We'll be back tomorrow.
I'll be back tomorrow.
So what other questions we got?
Rebecca?
Yes. I don't have questions. I just sit and listen.
Was the kinematics graphs, were those like the velocity time? Is that what that is?
Yep.
Oh,
You
okay.
probably memorize the car graph and
The kinematics graphs are your stachographs, your position, velocity, acceleration.
Okay,
Oh, this is my first exam.
Your first
Yeah, physics is my first ever. My first 3 exams are physics,
I'm gonna look.
math, and English.
Oh, that sucks.
Yeah, it does.
What else we need?
An applied force is like when something is being pushed.
Yep.
Okay.
An applied force means that there's some other object that is
What?
basically pushing the object.
Friction. You have friction in all of yours.
Well, I wasn't sure. You can see like I scribbled it out lightly to see. I don't know. So like in case it did count, I just only scribbled it out lightly.
I'm gonna go because my dad's gonna be here at 45.
So here, if you want this, we have a number of forces that we can list.
Oh yes,
So
that would.
if you want the list of forces that I kind of expect you to be able to label, we're going to have force of tension. When do we have a tension?
Like when it's a string or
When there's a
something.
string.
Something pulling. Who dropped this?
Then we
Oh, thank
also
you.
have F sub G,
Force of gravity.
which is gravity. When do we have gravity?
Always?
When we're on Earth.
Yeah, when we're on Earth.
Planet.
So basically all the time.
Earth.
We're going to have a normal force. When do we have a normal force?
When it's like on the ground.
When we're resting on a surface. What direction is the normal force pointed?
Like opposite the surface.
What do you mean opposite the surface?
Well, if it's like on the ground, it'd be.
Use the mathy word. What's the mathy word?
Perpendicular.
Yeah, perpendicular.
Matthew word. I just remember that because I get to draw squares.
F sub F is friction. When do we have friction?
When an object is moving.
Or when there is an object that wants an object, or when there's a force that wants to move an object, right? Because we can have friction even if an object isn't moving if I'm not pulling hard enough. like the activity or like the worksheet we did today.
Jeez, these are specific pens.
They're from Japan.
Wowza. Do they work good?
Yeah, they do.
What direction is friction?
Opposite the way it's moving.
Opposite what force?
The force
Applied force.
Well, it's opposite whatever direction we're moving. It's always going to be parallel to our surface. So we'll say parallel to surface opposes motion. We've got tension, we've got force gravity, we've got force normal, we've got force friction.
Fine.
F sub A going to be an applied force. When do we have an applied force?
When like, something's moving? Or
Not always.
That's a good question.
An applied force just means that something's pushing it.
Oh, okay.
Do we have any other forces we need here?
Is there no such thing as force of acceleration, or is that just like acceleration is its own thing?
Well, if we have an acceleration, that's going to come from a force, but the acceleration is going to be in the direction of the net force. That's why I don't want to see your net force on your force diagrams, because net force itself isn't a thing. Force of
Okay.
acceleration isn't a thing. It's just whatever the net force is that the object experiences, that is the direction that the object will be accelerating.
Okay. I don't think I have anything more.
Okay,
So-
that's fine. Are we good?
Yeah.
Okay. We got a good hour and basically an hour in because I had to putz around. I think tomorrow is...
It's Bergman.
Is it Bergman?
Yeah, 3:30.
So he will be live streaming.
Okay.
I don't know how he will push out the link to everyone else, but I will have to get the link for my stream to Mr. Bergman and Mrs. Wetstein, so that's available. And then
Alright.
my next review session is next week, Monday. But there's one tomorrow, then there's one Monday, then there's one Tuesday before school, and there's one Tuesday after school, and then there's one Thursday. And I'm considering doing another one on Saturday the 13th, but we'll need to talk about whether or not students feel like that will be valuable.
Would that be here? Or
I
like
mean,
in this classroom?
if I did it over the weekend,
Yeah. Okay.
Yep, it'd be in here. Okay. Well, I guess that's gonna wrap it up. I gotta turn it off from here.
How many people